It is August 12, 2026. This research overview is AI-generated, based on a partial daily collection, and requires human review. Across the 23 analyzed papers, the clearest theme is a gap between ambitious agent designs and what current systems can reliably do over time. We will focus on persistent assistance, selective evidence processing, deployment efficiency, visual geometry, and stress tests that reveal weaknesses hidden by ordinary scores.
Persistent assistance produced the starkest measurements. In a benchmark of 200 simulated multi-week life tasks, the best-tested model averaged only 32.5 points out of 100 across 3 runs. Across models, proactivity checks passed between 16 and 33.6%, while persistence and bookkeeping passed between 18.9 and 28%. These are benchmark results from scripted offline services, not estimates of real-world failure rates, but they show that maintaining plans through silent changes remains difficult.
A companion benchmark helps separate memory over time from finding the right information. On 250 mobile assistant tasks involving records scattered across applications, the best configuration reached 57.3% exact accuracy. More revealingly, supplying the relevant records directly raised average accuracy across configurations from 35.5 to 66.8%. That measured jump suggests information localization is a major bottleneck. It does not prove retrieval is the only problem, because planning and execution can still fail after the records are found.
The source also connects those benchmarks to a conceptual framework for human-centered agents. That framework calls for longitudinal memory, consent boundaries, intervention tracking, uncertainty, reversibility, and preservation of human agency. But it reports no prototype or outcome study, so the framework is an author proposal, while the benchmark scores are measured evidence. An editorial inference is that combining Oracle records, explicit versus silent updates, and persistence switched on or off could reveal whether a failure came from retrieval, memory, planning, or unauthorized action.
A second theme is that processing everything at maximum detail is often wasteful. In one deep research pipeline, post-retrieval pruning reduced average token use from 375,400 to 114,600, and runtime from roughly 3,423 seconds to 1,380. Judged quality moved only from 57.83 to 56.62. A two-stage configuration even reported higher judged quality with substantial savings, but quality depended on an automated judge. The study used one agent pipeline, and some configuration values were internally inconsistent.
Document understanding showed a similar coarse-to-fine pattern. An agent first inspected low-resolution pages, then zoomed into selected regions. At 70 dots per inch, it scored 70.6% average accuracy, compared with 69.4% for a 140 dot per inch baseline, while using 66% fewer tokens and 54% lower latency. Separately, a retrieval system that cached contextualized text nuggets achieved 41.7 average token level F1 with 81 milliseconds at the 99th percentile for first token latency, beating the strongest reported baseline under the same 100 millisecond constraint.
Together, those papers support hierarchical evidence acquisition. Narrow the search before spending expensive context or visual resolution. A compact visual document retriever could rank pages before region-level inspection, and cached text nuggets could reduce repeated long context work. That composition is an editorial integration proposal, not a demonstrated system. The open experiment is to combine page retrieval, region zooming, branch pruning, and nugget caching, then measure accuracy, evidence recall, factual errors, tokens, storage, and latency, while removing each component in turn.
Deployment compression also looked promising, though qualifications matter. A recommendation mixture of experts method reported speedups from 1.28 to 1.63 times, while retaining between 99.92 and 102.30% of the source ranking score for 4 expert checkpoints. Those endpoints included supervised adaptation and came from one A100 setup, so compression alone cannot receive all the credit. A visual retriever compressed an 8.1 billion parameter teacher into a 524 million parameter dual encoder and reached 61.74 average ranking quality versus 71.05 for the teacher.
Vision papers turned generative priors into explicit geometry in 2 settings. One decoded compatible video model latents into cameras and dynamic 4-dimensional scenes, scoring 61.60 on a projection similarity measure versus 55.79 for a matched generate then reconstruct cascade. Another inferred articulated parts and joints from a closed object at rest, reporting part segmentation overlap of 0.88 and joint type accuracy of 74.49% on one subset. Neither result is full physical validation. Projection similarity is not metric geometry, and joint errors excluded wrongly classified joint types.
Controlled stress tests exposed fragility that headline accuracy can conceal. When preferred word initial tokens were blocked during decoding, instruction tuning greatly improved retained math performance for several model families, including a rise from 25 to 90% in one matched base-to-instruction comparison. Yet another family barely improved, and rigid code formats largely collapsed under the intervention. In a jigsaw benchmark, supervised models exceeded 97% piece accuracy on 4x4 puzzles, then fell to roughly 3 to 5% at 12x12.
Self-evolving agents delivered intriguing but uncertain results. A coding agent evolution method scored 93.2% on a 60-task multilingual subset versus 77.9% for its comparison method under matched search budgets. A skill compression system shortened procedural skills by 31.2% on average, with a macro task score of 0.577 versus 0.570 before compression. The first study had few complete evolution seeds and an unresolved conflicting score elsewhere in its source. The second reported no uncertainty estimates and guarantees only preservation of parser-extracted structure.
The concise takeaway is that selective evidence use can cut cost sharply, while persistent autonomous work remains unreliable and difficult to diagnose. The most useful next studies should separate retrieval, memory, and planning failures, test structured ledgers over long horizons, evaluate geometry against metric ground truth, repeat self-evolution across seeds, and validate visual and translation gains with independent human judgment. Because this was a partial run with several truncated or missing source sections, treat small differences cautiously. For paper-level results, caveats, and links, see the linked daily summary.